There's a little bit of lag. I'm just going to start. All right. Thank you, everybody, for joining us today. Welcome to today's cybersecurity seminar. Yeah. Cool. I'm Dr. Stan. Some of you know me. Hi again. I'm excited to present today Dr. Christoph Kerschbaumer. He comes to us from Austria, where he works for Mozilla as the manager of security engineering. It's super exciting. One thing that you might not know about him is that he is a certified ski and snowboard instructor. So if you find yourself in Austria and want to learn to ski, he's your man. But today, we're not going to talk about that. Instead, we're going to be talking about a secure and privacy-preserving web. So with no further ado, let me welcome Dr. Kerschbaumer.
So much, Sid. It's super nice to be here, and I think it took me 5 years. Like Sid invited me so many times. Unfortunately, a pandemic was in between. But lucky for you and lucky for me, I'm here today, and I'm super excited. This will be a very smooth talk. I want to introduce you to a few concepts, and all of you know the web was not built with security in mind, and now we need to fix it, right? So I will guide you through in the next 40, 45 minutes what we have done over the past to get more HTTPS adoption. We will see in detail what that means and what it takes out of what it will take us to actually get to a fully secure and privacy respecting web we all serve. But before we do that, I want to show you something. As Sid said, I worked for Mozilla and we built the Firefox browser. So I want to give you some facts around that, and you will see it's quite interesting and probably not what you expect. All right, what is Firefox? Real quick, probably, I hope a lot of you have used it before. It's a free and open source web browser that was established in 2002, but now it gets more interesting. I know you all write programs, you do projects, you're in school, and you can tell me how many lines of code you've written so far. And you can also have a guess for yourself how big Firefox is. And it's quite mind-blowing. It still is to me. So Firefox consists of roughly 4 million lines of C++ and an additional 3 million lines of Java. As you can see, it's quite a massive code base. And in addition, we have contributors all around the world. Have a guess how many commits we have, how many contributors we have. Also very interesting. And it is roughly, it depends on the year, but on average, we have like 1,500 contributors, literally all over the world. And any given year, we have something like 60,000 change sets. So some of these change sets are security. A lot of the others are improving the user experience for our users. But today we talk about security. We good? We talk about security. And so here's a plot, and we will come back to that. So now we take it super easy. Again, this is a very smooth talk. Let's do a joyride together, basically. Let me be your driver, let me be your tour guide, and I'll guide you. So we want to figure out during our joyride how we got here to 80% of HTTPS adoption, and we will hear in a second what that means in detail, but also how we get up here, and that is a fully secure and privacy respecting web. This is the first exit. And I saw it somewhere on the wall today. There was a picture of Tim. And it's 30 years from introducing the web. And it was Tim Berners-Lee who actually posted a blog post on the W3C webpage. And he said, try it. That was in 1991, over 30 years ago. And again, the web was not built with security and privacy in mind. Back then, everything was over HTTP. And now I want to introduce you real quick to the difference between HTTP and HTTPS. Probably you know HTTP, Hypertext Transfer Protocol, transfers data in clear text. So for example, whenever you retrieve something from the server, anyone on the network basically can do that. It says here, hello, Rose. Students, I'm very excited. But also every attacker, as I said, can view, steal, modify that content. And in particular, when we talk about secure messaging or whenever we put in our credit card numbers, we want to make sure that those guys don't sneak around and steal any of our information. So this is how the web started out using HTTP. And HTTPS came along, HTTP or carrying HTTP over the TLS allows us to establish a secure and encrypted connection. So then it's not saying rows, homeland students on the network anymore, not in clear text at least. And that basically prevents the attackers from snooping around in our private data. Now that we have HTTPS, that still doesn't mean that all the connections can rely on HTTPS. But for those web services, web applications, web service that supported HTTPS, we wanted to make sure that those are actually connected through HTTPS. So and whenever I talk about we, it's not we only at Mozilla, it is we, the internet community, it is we, the WWDC, it is we, the IETF, right? It's big efforts. So talking about HSTS, HTTP, strict transport security. But here, don't get confused again. When you connect to a website, the browser enables an HTTP connection. Then, if a web service supports HTTPS, it redirects you to HTTPS, and the browser has then make another connection using HTTPS, and then finally the server can set the HSTS header. Once that information is sent and retrieved by the browser, it kind of signals the browser, please, I speak HTTPS, please connect only using HTTPS. We cache that in the browser, and from that point on forward, the server is always connecting using HTTPS. So still, the problem is that the first connect happens over HTTP. So there are some drawbacks to that. The initial request is HTTP, but then also it's too scary for a lot of our banking websites, big social media websites to be connected over HTTP, even for that first time. So what we started doing is incorporating HSTS preload lists into the browser. And I looked it up, I think yesterday. Currently we have roughly 125,000 entries. And when you are in the HSTS preload list, we even made that first connect using HTTPS. And again, this is not only specific to Firefox, this is in all other major browsers as well. As you can see, 125,000 page. The web at the moment, have a guess for yourself, there's billions of websites, right? So obviously that approach doesn't scale with the size of people. So we need something better. This content walking, again, I'm telling you so many initiatives to slowly increase HTTPS adoption to the maximum, right? Whenever HTTPS is available, we should make use of it. So mixed content walking came along. And that means the top level site is HTTPS, but then there were still insecure sub-resources on that page. And that can be quite dangerous when you think about scripts that really have access to the DOM and can modify the entire web page and also exfiltrate it. If that is over HTTP, the attacker can still modify the script on the fly while passing through the network and then modify the web site. So what mixed content blocking did is it basically blocked dangerous content, and dangerous content means scripts and styles, but allowed not so dangerous content, like images, video, audio. But interesting fact here, what actually happened in the wild is that the mixed content blocker, again, allowed images to pass through. And what an attacker did is basically it swapped the images. So basically, instead of clicking the accept button or the deny button, the actual images were flipped. So the red button was the green button was the red button, but underneath the logic remained the same. So you basically thought you clicked deny, but in fact you accepted whatever was to accept here. So very nifty. More came along. CSP block owns content. So CSP, probably you've heard of that. If not, I'll do a quick summary. It's the content security policy header. And not only that, it's not only a header, you can also use it as a meta tag. For simplicity, I use the meta tag here. So in your HTML, you place something like this, and you can say in the CSP, block all mixed content. And website I started using that in particular because it allows you to catch flaws in the development cycle very, very early on. When your developers accidentally used HTTP content in an HTTPS site, it was blocked during the development phase, and they instantly were able to fix it. And also ensure that no HTTP content appeared on the HTTPS site. Yeah. Said that, so this is really good. It doesn't allow images, it really blocks all HTTP content in an HTTPS site. But we need more than that, right? Like we the community kept observing what's going on, where we can improve, what we can do better. We can raise HTTPS adoption on the web. And there is another CSP directive, which is called upgrading secure requests. So very similar, you can place it in an HTTP response header, or also for simplicity here in a meta tag. But when saying CSP or using upgrading secure requests, it brute forces all connections from HTTP to use HTTPS. And this makes a lot of sense for massive web archiving kind of websites, right? Like when you think about the BBC, they have such amount of legacy content that it's physically impossible to rewrite to HTTPS. But they make sure their servers support HTTPS, so they use that directly, for example, to brute force the upgrade. And we have Let's Encrypt. However, you know, and probably you know that you need as a website or web application need a certificate in order to support HTTPS. And then Let's Encrypt came along, and Let's Encrypt allowed to completely automate the process of getting the TLS certificate. When we look at the numbers here, so Let's Encrypt was launched in 2016. Back then, the HTTPS adoption rate that we measured was roughly around 40%. And only within like 5 years, not only Let's Encrypt, but mostly Let's Encrypt, also these other initiatives. And then we went up to like 80% in less than 5 years. So this is a massive improvement. And we can see is what we learned from that is when you make security easy to use, people will use it. If it's hard to use, then obviously people will rather invest their time in something else. Stopping FTP support. People even remember what FTP is. FTP was very popular years ago, but it suffers from the same problems as HTTP. And it transfers data in clear text. And even worse, HSDS header does not apply to FTP content. And this was baked into the browser, I don't know, like 20 years ago. And only very recently, we were able to completely eliminate it. We started with not allowing FTP resources in other HTTP web content. And slowly we got it out of the system. And in Firefox and also in other major browsers, you cannot use FTP. Again, you see it's one little step after the other of slowly cleaning up and getting ready for the secure web. Blocking insecure downloads, this is another one. So we started with blocking insecure downloads. If you are on a secure website, and for example, you download your payment statement or whatever bank statement, right? If that was over HTTP, again, your HTTPS side of your bank was secure, but the download was then again transferred in clear text, and the attackers were able to see that. I don't want anyone on the web to see my bank statements. So we started, again, slow baby steps. We started by not allowing HTTP downloads in HTTPS page. And actually, in 3 weeks from now, spoiler, we are finally able to block HTTP downloads everywhere. It's again one step up. And even here, we are very cautious, meaning we block it initially, but we allow the end user to override our decision if they need to for whatever reason. So this is how we got here. We do a little stop, get some water, some refreshments. And now it's getting really exciting. Over the past few years, I've been putting a lot of effort in what I'm going to tell you next. And even though it might sound easy when you see the slides, and, oh yeah, that's so obvious, I can tell you it's not. And the reason for that is that the web is misconfigured left and right, and it is kind of the browser's job to make up for it and to provide a very good user experience. So it's called HTTP assembly mode. Very similar mode in other browsers. And again, it's obvious now. And it wasn't so obvious. And we started doing that as kind of the first browser. It started off very easily, but in the end, we got better. We wrote a research paper, and we even won the best paper award for it. And by now, all the other browsers are supporting very similar initiatives and similar modes incorporated. Signing the paper here as well in case of it. But on a very high level, industry default, if you enter http-example.com in the URL bar, or even you omit the scheme and just type example.com, or you click an HTTP link on the web, the default is that you will connect over HTTP to that website. The HTTP-only approach is, well, can we change that? And can we go to HTTPS first, or probably if HTTPS is available? And only if it's not available, fall back to the insecure HTTP protocol. And again, I always make that analogy of burning books, right? Like, I don't want to eliminate any kind of content. What I want is we increase the secure connection model and try to connect using HTTPS. And if that is not available, we go back to HTTP. But it shouldn't be that content on the web is not accessible. Because there are a lot of reasons why you cannot maintain your website anymore or your web application, but it still contains valuable content for some people on the site. So remember that slide. Now it's called to get across the point. The current connection model is that we still connect over HTTP first, and we do an entire dance of redirect to HTTPS, and all of a sudden we can set HSDS header, and from that point on forward, we connect to HTTPS. So the HTTPS only connection model is different, as I just said. Here's colors, so it's really easier to follow. We try to connect using HTTPS. Not available, we fall back to HTTP. But it is an optional GET request here, because HTTPS only provides the guarantee for the end user that there will not be an HTTP connection without your explicit consent to use. If it's not available, we provide that in the decision page, and then you can make a conscious decision for yourself. Again, this was mostly for the research prototype that we did. And in Firefox, that mode is still available. But what we learned through our measurements is people don't want to go through the decision page. At some point, they want, basically what they want is Firefox. Make it secure if you can, and if you can, just give me the content. And that is a fair thing to say, and I get that. But again, the HTTPS only approach is, what the guarantee is no HTTP connection without the explicit content. Once we can get that to mainstream Firefox, right, we will provide that on the default. So again, there are some challenges, and I will tell you, I cannot tell you everything in detail, but this one is very interesting. Okay, so we try to connect using HTTPS, and then we wait for 3,000 milliseconds. And that, again, it sounds so easy now in retrospect to keep back at that. But finding those 3,000 milliseconds took us forever. And the reason for that is we provide Firefox in so many different countries. Firefox is on mobile, on the phone. There are so many constraints, latency, network, whatever it is. So trial and error approach, empirical evaluation for us 3,000 seconds is a good wait time. If we get back an error earlier, then we provide that interstitial page. But if we don't receive any kind of signal within those 3,000 milliseconds, we send an anonymous background request to that domain. And we script any kind of head or query parameters or cookies. We just want to see if that server responds to an HTTPS connection. And if that background request returns a result faster than the initial request, then this is a very strong indicator that the website is not available for HTTPS. Again, it sounds so obvious and so easy. One of the problems we figured here was that web applications are hiding or sitting behind a firewall that just drops all HTTPS packets. And there is nothing you can do. The server will not respond at all, and packets will be dropped. You keep waiting. But then we have that strong indicator. We can provide the interstitial stage, and people can connect using HTTP. So what is the success rate of top-level upgrades? Of the pages that we visited, or actually it was, I think, 100,000 end users that opted into our study and helped us really getting that. And the pages that were not available over HTTPS or HTTP content, we were able to upgrade 73% to HTTPS. That is a big win, right? That is a massive win. And 26% resulted in an exception page. So how does that look like on the grand scheme? In that study, which was mostly in the US to be fair, 92%, almost 93% was HTTPS to begin with. So no need for HTTPS on remote interconnection. We had 3.5% successful upgrades to HTTPS and 3.7% where the end user opted into displaying HTTP. So again, slowly we are raising the bar and getting more and more HTTPS adopted, and it makes me really happy to present those numbers. So when visiting 1,000 pages, the median user experienced 4.3 exception pages, right? 34%, so no exception pages whatsoever, and 95% of users got fewer than 0.8 exception pages, which is really good. And again, slowly we are getting there. We're getting there. We are getting there. The goal is 100% HTTPS adoption, even though, quite frank and to be fair, it's a goal that is hard to reach, in particular because I said so many old applications are not maintained. And I'll tell you the story about that because there is so much legacy code in Firefox. Right? Whenever I try to deprecate an API, we do all of the steps necessary. Right? We announce it on websites. We log to the console that this API will go away. And we do all the steps. But when the day finally comes and we actually turn off the API, you can be sure you have 100 emails tomorrow morning. Why did you turn this off? Can you turn it back on? I'm still in support. And very similar here to HTTP content. They're all web servers and web applications around that just rely on the fact that you can connect to a web service. I encourage you, if you are Firefox users, to enable HTTPS on your phone. It's really easy actually. You go to about preferences and you look for security and privacy, and then the default is don't enable HTTPS on the mode, and you just hit that toggle to always enable it or enable it in your private browsing mode, if you like. In fact, in private browsing mode, we have something enabled that is called HTTPS first. So that tried to upgrade, but then suddenly it was back to HTTP. It's not available. And it seems to work pretty well. But again, to get here was hard because web servers are configurated, as you can imagine. And I'll tell you the story about that as well. Because we thought quite often what we see is endless redirect loops. We upgrade to HTTPS. They said, well, I don't speak HTTPS, connect using HTTP. So it comes back as HTTP, we upgrade again. And there are all kinds of heuristics that we have applied to break that cycle, right? Because it downgrades an end user's experience. And the web is misconfigured. So one thing that we have encountered is we upgrade, it is an internal redirect, an HTTP page with a different head. We try to upgrade again. The second upgrade, they go to a different page, we have a meta redirect, get to another page, we upgrade again, it comes back, they set JavaScript, you use JavaScript document domain, you get a different location. So as you can see, it's really, really hard to build heuristics into a browser that successfully can break all the potential options that happen. Haven't reached a fully secure web yet. Not quite. Initiatives like HTTPS only definitely point the way. But we also have to grant additional privacy needs. And again, the way I see this is initially we had HTTP for the web. Then we started with Web 1.0, where we started to buy stuff over the internet. So we started to enter credit card numbers, right? And that information, like the credit card number that you enter into a website, is secure when the connection is over HTTPS. But there are still privacy needs whenever you connect to a website. And governments or ISPs mostly use information that is here for censorship. We need a way to establish better mechanisms that keep us safe, we as end users. So one thing here is I'm going to tell you about 3 initiatives here that Mozilla is heavily investing. Again, only at a very high level because obviously it's complicated, but I want you that you at least have heard about those initiatives because they are important for all of our apps. So the first one is DNS over HTTPS. As you remember, in the beginning I showed you that slide, right? And once we have an HTTPS standard established, we are good from that point on. But there is stuff that happens earlier when we actually connect and establish that secure channel. First, we need to resolve the DNS because whenever we connect to a server on the internet, it is actually not the human readable example.com, but we connect to the DNS resolve button and provides an IP address which the browser then uses to actually establish a connection. As you can see here, that is all in clear text, so our need-to-be attacker comes in again and we can see that we are going to example.com. And this is actually a real thing, right? Governments use them for censorship. This is the #1 purpose to implement censorship. So using DNS over HTTPS, we encrypt the DNS lookup with the DNS response. And again, this sounds so easy, right? Just encrypt it and you're good to go. But there was way more involved in doing just that. Because obviously the DNS resolve is the same protocol. So we need to partner up and find DNS resolvers who actually want to work with us. On top of that, there are legal implications in various countries where you cannot instate it. Right? So it's not only an engineering effort, it's also a legal effort, a policy to actually ship that by default. I think we started shipping DNS over HTTPS by default in the US in 2020 or 2021. And this works pretty well. But again, only for the US. There are countries outside of the US who cannot benefit from that at the moment. But we're working on it to get more partners. The next one here is encrypted client hello. And the funny thing is, We need all of the three things that I'm telling you right now. We need all of them to be applied at the same time, because otherwise we need the same information. The network attacker can read that information. So encrypted client hello, or short ECH. Again, once we have the secure tunnel established, we're in good state. But earlier than that, when we actually do the TLS handshake with the server, right, we send interclient hello message that we may name in plain text. And again, the attacker can read it because that leaves bits of information that we don't want. So again, we encrypt the client hello message again. Sounds so easy again, but it's also a lot of information, and you need to apply additional heading. You referred to it earlier in 6 class. Make sure that all these client hello messages look identical, whether it actually encrypts it or not, depending on the partner or not, the country or not. Good. CLI, the next one. Again, once we have established the security channel, we're good, but before that, we need to do stuff. And as we have heard earlier, with Let's Encrypt, it allows you to automatically retrieve a certificate for your website. But there can also be instances when your certificate got compromised, is not valid anymore. You, as a web application server, can revoke the certificate, or also the CA can revoke the certificate. The browser needs to know that it got revoked, so we actually don't establish that secure connection. So what happens in the background is when you connect to a website, let's say exam.com, in the background, it sends an OCSP request, the online certificate status protocol request, to a CRL server, which then provides an answer whether that certificate is still. Not only is it a problem that there is an HTTP request, so again, it leaves the information, but also one of the problems is that it fails open, which means if the request doesn't return any result, it means we trust only we as Firefox. So we're community trust that the certificate is still in. And that is obviously a problem for security reasons, but also a privacy problem. So what we have done, again, the attacker can see that on the web. So what we have done is invent something like CR-Lite. And what CR-Lite does, it takes all the CRL data, and this is massive. This is billions of certificates. And it extracts information, and it builds actually a cascading room filter. But for simplicity, let's call it a room filter. And we can probe that. It returns a result. Is example.com, does it have a valid certificate at any given point in time? That room filter will return yes, and you can rely on information. So everything around that will be, whenever we package and ship Firefox, we send a new filter, right? And we ship Firefox every month. But in between, we need to update those filters, right? Because a certificate can be revoked on the 15th of the month. And then we send small packets of information to the browser and update it. But either way, the good thing is that we can do revocation checks in the browser. And it's accurate, right? It doesn't fail, it's precise answer. So this at the moment, CLI, again, sounds so easy to ship that to 1% of the user population at the moment, and we are testing that. But we're getting good results. What we want to make sure that we not accidentally label a certificate as revoked. Hence, it takes a whole lot of testing, and a whole lot means years of testing. But we are getting closer to get that out to more of our users. We are considering 5% of our users in space. Again, it's a funny when I look at it here. It seems like you think, oh, this is all small. It's one step at a time, and it takes a long time. But we are getting there. We are really getting there. Again, the question is, and we're coming towards the end of the talk, Have we reached a fully secure and privacy respecting web yet? Not quite, but we're getting there. Initiatives like HTTPS only, DNS over HTTPS, ECH, CLI, those all went away. Slowly raise the bar to finally get to a point to have an internet web that we all want, that is secure and privacy respecting. I want to close today with something that is very important to me personally. And it's a privilege to work with people who are passionate about building what we want, free, independent, and secure. That includes every one of you here as well, because I know you study computer science, you're the next generation that will help us achieve that goal. Maybe some of you are interested in a career at Mozilla, or even at other brands of business. Security and privacy for sure. Security and talk. At the very end, lots of familiar faces from the morning. I know not all of you got a chance to grab the free book. What I did is for those Holman students, if you go to that website, it's BYDC for beyondthecode.info prologue, you can get a chapter for free and get a peek and learn something through that. Thanks for having me. Hopefully I was able to give you insights on what we do to build a privacy or a secure and privacy respecting web. And I'm very, very eager to hear all of your questions. And again, it doesn't need to be only about that. Like, feel free to ask me anything. Well, what do I need to do to increase my chances to land a job as a company company? Right now? Ask you questions around what the day-to-day looks like, what is stressful, what is not, what about traveling, whatever interests you, I'll answer all of your questions. Because I remember I was once sitting in that audience and I would have wanted someone who comes and answers all of those questions for me so I can make better decisions for myself. Thank you so much.
All right, let's thank Christoph. Got a question? Raise your hand. You can just pick on whoever you want.
I'll turn it off now.
No, we'll do a big group Q&A for a few minutes and then yeah, pick on whoever you want.
What do you think is the next type of protocol that now like FTP? All right, so they're not be supported.
I think FTP was the one that was important to nuke, right? HTTP will be around, but FTP is slowly got deprecated anyway to work with the natural next step. The other thing where we put in a lot of effort is securing the file protocol, and it allows you to access the local file system. And then even though we are trying hard, when I say we are trying hard, there are actually 20 people working on those kind of programs, right? And those are very difficult. But it's still possible to access the local file system. For example, even though it was not Firefox's problem per se, but so what happened is send a link to someone on WhatsApp, for example. That person downloaded that HTML page, right? And then opened it on the phone using the local file system. And when you open something on the local file system, it has access to other files. Right? But you still would need to know where the files are located. So the problem that was with WhatsApp is basically they stored all their numbers in incremental numbers, all their pictures in incremental numbers. So the first picture was called 0.JPEG, the second was 1.JPEG. So basically what happened is that the attacker basically just went through or probed how far can I go, take all the pictures and upload it and send it to us. Not really Firefox problem, but the web problem that exists, right? Currently, no one really thought of it. Obviously, we reach out to them and together we fix that more efficiently. It was a problem.
Instead of many web browsers are starting to implement something a little bit like HTTPS only, is there any major web browser that's just completely behind the curve that you just wouldn't recommend for privacy or security reasons at all?
Well, the funny thing is, if you look a little closer, there are only 3 major engines, right? Most of the browsers are Chromium based these days. Then we have Gecko, which powers Firefox, and then we have WebKit on Safari. And yeah, everything that is in the platform, so whatever it is in Chromium that comes to Brave, that comes to Opera, and all the other Chromium-based processes. So, yeah. I guess what I can say though is make a conscious decision what browser you use, right? I'm not saying that anyone is so much better than the other one, but if you do a little bit of research and invest, say, an hour and read up a little bit, then it helps you a whole lot. And earlier in SIDS class, we figured that you actually can configure your browser, right? There are a lot. But the number one question I get from students is, what preferences do I have to put? And yeah, I can say HTTPS only mode is a good one. Privacy resist fingerprinting is another one. But obviously, it comes with the trade-off, right? That it breaks websites. More questions, please.
If you were a soup, what kind of soup would you be?
Sorry,
If you were a soup, what kind of soup would you be?
a soup.
Yes.
What is a soup?
Like
clam chowder,
Oh,
chicken
a
noodle.
like a soup.
Yeah.
Huh.
If you were a soup, what kind of soup would you be?
What kind of soup would I be? There's a special thing in Austria, and it's pancake striped soup. It's the most delicious thing you can imagine. My daughter is having it every single day, basically, whenever we go to restaurants. I would go.
Do you have any thoughts on the recent XC backdoor?
Yeah, see back.
Are you aware of it? You should look it up. It's a good one.
Okay.
Pretty great. I don't really know enough about it, so.
Okay. I'll check that out. Thanks.
Obviously, a lot of this work involves like making the encryption between the user's device and the intended recipient. What steps can be taken to increase privacy when the intended recipients aren't following like standard security protocols? Like, for example, when huge businesses and corporations are just selling user data without user consent.
Yeah, this is obviously a very hard one as opposed to one of the legal one and a technical problem. What we see in the world is, I think also what I mentioned earlier, but that's encrypted. If security gets easy to be applied to your system, and companies will use it, right? Like most of the companies are able to generate some form of profit, right? There's nothing wrong with that. It's completely fine. But if it's hard to apply security to your system, then most likely, this is also what we see in the real world, is that companies rather buy massive amounts of insurance rather than investing in security, because that is the cheaper option. Go ahead.
For the HTTPS only, you wait 3 seconds on the case where there's like no traffic. Why not send that anonymous HTTP probe immediately? Is it like web traffic, like congestion problem?
This empirically found that. So, for example, if you would send it, by the way, TLS takes a little longer than an HTTP connection. So, if you would send it by the way, the server would respond quicker, and we would kill the other connection and display it as the shrinkage. And we don't want any. So we have to find kind of that sweet spot where it's still acceptable for an end user to wait. Still, right? Like waiting 3 seconds plus is a very long time. This is kind of, and again, in particular in the US, where you have roughly 93% of HTTPS in the web at the moment, right? Like this is a very good number, and very, very, very high. Yeah, please.
Are there any adversities you encountered in your field that you were not expecting going into it?
Can you refine the question?
Any going into cybersecurity, you have certain expectations. Were there any things that you encountered that were like, oh, I was not prepared for that?
I guess that's like, right, like there are so many things. What what I have learned along the way. So what is an expert, right? An expert is someone who has made all the possible mistakes in a very narrow field. Right? I think that is what everyone has to do. Someone asked me one question earlier today. He said, how much did you invest in learning programming? There is a very good book. I think it's called How to Learn C++ in 10,000 hours. Right? So you have to invest that kind of time to actually learn all these things. And failure is the important thing you have to come across and overcome and not. I see you all here. I'm pretty sure you have made mistakes and you will learn along with it.
All right, I think we're gonna end right here, so you can get to your next event if you're going to the other thing that also happens to be happening today. So let's thank Dr. Kerschbaumer one more time. And if you're here for CSSE 145, please stick around. We're going to take a break for about 5 minutes, probably 5 minutes, and then we'll shorten the second half of the class today.